I want to talk about area and perimeter. And in this video, we're going to talk about four-sided figures. Any kind of four-sided shape is called a quadrilateral. So that includes a square, a rectangle, lesser known ones like a like a parallelogram or a trapezoid. Perimeter, regardless of what kind of shape you're talking about, is the sum of the sides. The distance all the way around. I have sometimes seen people who said, well, they had a hard time remembering the formula for the perimeter of a rectangle. And I keep telling them they don't have to have a formula, it's just the sum of the sides. It's true that with a rectangle, your opposite sides are the same length. So if these two are the length and these two are the width, then the perimeter of this is going to be a length plus a width plus the second length plus the second width, which will be 2 times the length plus 2 times the width. But you certainly don't need to memorize a formula in order to do this. You just have to add up the 4 sides. The area of a rectangle let's clarify first that perimeter is always in a length measurement. So it's just going to be in feet or inches or meters or centimeters or miles or kilometers or whatever. It's strictly a length measurement. It's a length plus a length plus a length plus a length. The area is always going to be measured in square units. A square unit is when you have a square which is exactly 1 unit wide and 1 unit long. So if this, say, were an inch, if this was 1 inch by 1 inch, length times this, length times width would be 1 square inch. So 1 inch by 1 inch is 1 times 1 is 1. Inches times inches can actually be treated as square inches. And so sometimes they will put square inches in terms of treating it like a variable squared. If we have a rectangle here, which is, say, has a width of 2 and a length of 3, so that the perimeter here, if this is 2 and this is 3, the perimeter would be 2 plus 3 plus 2 plus 3, which is 10. The area, if, I know these don't look like squares, but pretend like these are squares, the area would consist of 1, 2, 3, 4, 5, 6 square units. 2 units by 3 units is always going to be 6 units. So 2 units by 3 units is going to be 6 units squared. Whereas this was just units plus units plus units plus units is 10 units. So the area of a rectangle is going to be length times the width. Where they tend to call the shorter one the width and the longer one the length, but it really doesn't matter. Now the area of a square because the length and the width are exactly the same. You could call it the length squared or the width squared, or sometimes they call it the side squared. Whatever you call it, it's that length squared. If we look at a parallelogram, now with a parallelogram, opposite sides are parallel, but you don't necessarily have 90-degree angles. With a parallelogram, if I took this corner over here and I cut it off, if I came straight down, I could actually move this over to here and fill it in there and create a rectangle. So the area of this parallelogram, well, we can't say it's this side times this side. And let me change the color a little bit so that we can see what's being added. So I took this corner and moved it over to here. It's this distance times this distance. Well, now this and this are the same. So we could still call that the length, but a lot of times they'll call it the base. This is not going to be the width. This is the height between the two opposite sides here, the bottom and the top. The height of a shape is the perpendicular distance. So it's at right angles to the other side. So with this parallelogram, the area is the height times the base. So it's the height times the base. So you have to find a way to figure out this height, or you have to be given the height. Let's look at a trapezoid. Let's look at the area of a trapezoid. Now, a trapezoid is where two of the sides are parallel, but the other two tend to be angled in toward each other. They will be. Now, with a trapezoid, if I were to take this and duplicate it, take the exact same shape, flip it upside down this way, so that this side stayed attached to this side, but now I've got the long side down here, up here. This one is going to come out like this. So that this altogether is two of the trapezoids. So the area is going to be 1/2 of the area of the resulting parallelogram. So it's 1/2 the area of the parallelogram created by putting two of these together. And that seems like a silly thing to do, except that we already know how to determine the area of a parallelogram. The area of the parallelogram is this height times, now the base, the distance here is going to be the two bases, they call them both bases. It's the two bases put together. So it's 1/2 times the height times these two bases put together. We've got the base, the bottom one times the top one here, the bottom one times the top one here. So the area is 1/2 times the height, the distance between the bases, times the sum of the bases. So we've got the area of a rectangle, area of a square, area of a parallelogram, is the height times the base, in which the height is not any of the sides. And then the area of a trapezoid is 1/2 times the height times the sum of the bases. You could think of this as the base of one of these. If I drew the parallelogram this way, if you take the two bases and get their average, which would be add the two bases together and divide by 2. So it's the length would be the average of the bases times the height. And that pretty well covers any kind of four-sided figures.